All right. So when we have, there's two different types of logs you can be given. Paying attention? You can be given logs, and then one of the terms is just a number, like 7, 4, 13, which we did yesterday, right? You put the number on one side, logs on the other, combine them as one log, convert, correct? That's the one way. So you have logs, and then you have one of the terms is just a number, okay? Or the second type, type 2, is every single one of these is what? Every single one of them has a log, correct? All right. So what we can do is we can do, pay attention, we can do what we did yesterday. So guys, we can go log x minus log 15 minus log 0.2 equals 1. Paying attention? So we could do what we did yesterday, because now we would have terms with logs in it on one side and number on the other. Base 10, base 10, base 10. So you get log base 10 of x in the numerator, and then 15 has a negative 1 in front, and 0.2 is a negative 1 in front, so I get 15 times 0.2 equals 1. Right? Okay, what's 15 times 0.2? So we're going to get log base 10 of x over 3 equals 1. Then what do I do? Exponential form. So the base of my log becomes the base of my exponent. What's friends? Say friends, so I'm going to get a 1. Equals x over 3. And then I multiply by 3. So x equals 30. So that's what we did yesterday. We got all the logs on the left, the number on the right convert. Yeah.
0.2 being times is like a minus. Like it's getting times.
Because if there's a negative 1 in front, it goes to the denominator.
Oh.
And then if there's more than one number in the denominator or in the numerator, they get multiplied.
Oh, okay.
So this one has a minus 1 in front, so the 15 drops to the denominator, minus 1 in front, 0.2 drops to the denominator, and if there's more than one term, they should multiply. Okay. All right, everyone paying attention? So that's type 1. We should just do what we did yesterday. Type 2 only works if you have all logs. So if I have log x minus log 15 equals log 0.2, if they're all logs, what we can do is we can make a common log. Remember we did common base, exponential, we made them all big base 2 or whatever, and then we solve them out. If we have all logs, we can make the logs go together on either side. So there's no just number here, right? There's no like plus 7 or something, correct? They all have logs. So I can put these together, and I can go log base, or base 10. Log base 10 of x over 15 equals log base 10 of 0.2. If that's true, what can you tell me? Log base 10 of x over 15 equals log base 10 of 0.2. What can you tell me? Yeah, x over 15 equals 0.2. If this is log base 10 of something equals log base 10 of something, then something's equal. Multiply by 15. Seems a little dicey. 3. Why did we get 30? Is 15 times 0.23? Yes.
It's not 10, it's 1.
Yeah, but it's 10 to the 1. Did I write the equation down right? I did. This would be 3. Something is done. So we get sorry? Yeah, oh, it's supposed to be 0. Guys, this is supposed to be 0. If you move them all over, what does it equal on this side? 0. What's 10 to the power of 0? 1. There we go. Stand. There we go. Personally, if you have all logs, it is easier just to get one side together, the other side together, and then set what's beside each other the same. It's easier. What's my restriction on this one? The only variable I have is this, and whatever's beside the log has to be what? Greater than 0, right? Alright, next page. You try that one. You try this one out. Okay, so they're all logs. So we're going to actually first say the restrictions. What's the restriction of this one?
X minus 1 must be greater.
X minus 1 has to be greater than 0. So x has to be greater than 1. And this one is x has to be greater than 0. Which one covers both? This one. If I drew a number line, 0 would be here, 1 would be here, so the double up is here. Okay. Now we have log base 3. This has a plus 1 and a plus 1 in front, so these are going to get multiplied in the numerator. And we get x minus 1, and then equals log base 3 of 6. So then we get log base 3 of x squared minus x equals log base 3 of 6. And so then, if we have log base 3 of this equals log base 3 of this, then they have to equal. So x squared minus x equals 6. And we're back to grade 11. What do we do? Do that. X squared minus x minus 6 equals 0. X minus 3x plus 2. So x equals negative 3. What's the problem with that? Doesn't fit our restriction, so it is rejected, and we have to write statement. And then x plus 2, sorry, I should have showed this middle step. X minus 3 equals 0. We have to show that step where you split them into equal to 0 or we lose marks.
X equals 3.
X equals plus 3.
Yeah, X minus.
So it's 9.
If we make a high pitched noise, we just forget that that all happened. But we don't skip this step. Point proven, that's what I was showing there. Okay, good job. Yeah, that's what I was doing. Totally testing you. It was not an honest mistake. It was me testing you. We don't make mistakes, we just test you. So when it's a mistake, we're testing it. Yes. That's what I'm going to go with. All right. What's our problem with 5? There's a 2 in front. Where can we move it to? So now we're going to get, first off, x has to be greater than 0 from the initial restriction. Then we're going to put them together, so we get log base 10 of x squared equals log base 10, guys. What are we going to do with the 3 and the 27? Both the plus ones in front. I'm give up. Oh my god.
Never give up.
Never give up. Thanks, Cole. X squared equals 81. And when I take the square root, what do we do?
Square root it.
I thought it was like a, pipe cleaner. I was like, why are you playing with pipe cleaner? No, you're playing with goggles. Okay.
Play with what?
Goggles.
Oh.
So x can, equals plus or minus 9. So we have to remember that. What's the catch with the negative 9? Yeah.
Listen, you're absolutely correct.
Okay, what did these say? They say try. What do you think I want you to do? Try. To point this out, this one is the same as yesterday, correct? This one is the same as today. Good. What's the problem with number 1? The 2 in front. So we do have to say our restrictions though. We have x is greater than 0, and x plus 3 is greater than 0, x is greater than negative 3. Which one covers both? X is what? So negative 3. Which one covers both? 0. Because here's negative 3. Here's 0. Where does the double up happen? After 0. Okay. So we bring the 2 up, we get log base 3 of x squared minus log base 3 of x plus 3 equals 3. So we get the log on the left and get them together. So we get log base 3, x squared goes in the numerator, x plus 3 in the denominator, equals 3. Then we get 3 to the 3 equals x squared over x plus 3. Then we get 27 equals x squared over x minus 3. Then what do we do? What can we do next? Multiply by this x minus 3. I do. Sometimes it's a blessing, sometimes it's a great thing. You guys, x squared minus 27x minus 81. That's 81, sorry. What multiplies to give you 81 and adds 27? Is there such a thing? What do we have to use?
Drag formula.
Yeah.
Oh, there you go.
Oh, it's x plus 3? Oh, yeah, you can add that.
Change there.
Not, well, yeah, but no.
Another test.
Another test. Thanks, Cole. I'm glad you guys are noticing all these tests.
Who else but Cole?
No one. So we need Cole. All right. So, A, B, C, eraser. X equals, did you say the quadratic formula is so much fun? That's what I heard. Great hearing. So that is exactly what Charlie said. You're welcome, Charlie. It's just a 1. Because I moved it to that side. So I get B, why there is B? I get positive 27 is minus 27, plus or minus negative 27 squared, minus 4 times 1 times negative 81, all over 2 times 1. So we get 27 plus or minus under there, I get 1053. And then it splits. 27 plus square root 1053 over two. 27 minus 1053 over two, that's an X. And markers for those. It's 29.72. Negative 2.72. Except it has to be greater than 0, right? This is extraneous. That's good.
Small.
When they're all three logs, life is a lot easier. So we can put these ones together. And if you don't like the minus, do we have to keep it on this side? We could move it to the other side, that's what I'm gonna do. They're all logs anyways. Log base 4 of 8 plus log base 4 of 2x minus 3. Log base 4 of x plus 1 equals log base 4 of 8 times 2x minus 3. X plus 1 equals 16x minus 24. Subtract x. 1 equals 15x minus 24. Add the 24 over. 25 equals 15x. Divided by 15. X equals 5 over 3. And our restrictions are x plus 1 has to be greater than 0. And 2x minus 3 has to be greater than 0. So this is x is greater than negative 1. This is 2x is greater than 3. X is greater than 3 over 2. Which is 1.5. So this is the order one.